If you don't mind, let's go back on a few things which are still a little vague for me.
Yeah, no problem. I understand it's not easy. What shall I start with?
Well, for a start, you could talk about the context.
So, imagine Antarctica. From August to November 2010, temperatures from -15 to -40 degrees Celsius, and a team of 18 people going to the American base of McMurdo.
Who can enjoy a country where you have to wear 5 layers of clothes to go outside?
It's not a country, it's an international continent, open to scientists of the whole world and still protected from our worldwide economic system. That's one of the reasons it's fragile and that its future is under threat.
Okay, and concerning you, your work?
The campaign to release balloons.
Balloons? Inflatable ones?
Stratospheric balloon, capable of flying for many months.
Your measurements are in the balloons?
No, in fact we attach our instruments in a sort of gondola, which flies behind the balloon. Look.
Ah, I never imagined it was so big, but why balloons? Why not a plane or even a satellite? The CNES is the French space agency, is it not?
Only balloons enable us to get to the stratosphere and take measurements. There, look. Here, the South Pole. On this region of the Earth, there's a natural phenomenon, the vortex. It's a vast whirlwind which forms in the stratosphere during winter. Its study enables to understand better the way the global climate of the Earth works, and the measures are then confronted to those of the satellites and meteorological models.
You work with meteorologists?
Yeah, from Meteor France, scientists of the CNRS and Americans of the NCAR, and of the universities of Wyoming, Colorado and Indiana. We become one big family when we go to McMurdo, you know. All very passionate, a little crazy too.
Yes, from that point of view it looks nice.
And believe me, it is.
Let's go back to our measurements. Start with YASI maybe.
Be careful. You must know that YASI is the instrument of a meteorological satellite. It's an infrared instrument which observes the air columns and gives an idea of the pressure, the temperature and humidity of the atmosphere all over the Earth. This means from its surface up to an altitude of 50 kilometers. Basically, the meteorological simulations feed on these measurements, so they help the forecast.
And these measurements are not enough?
It's an infrared spectrometer. At the pole, because of the cold, the signal given by YASI is difficult to interpret correctly.
That's why you have all those instruments?
Yes, and especially the dropsondes developed by the Americans.
The dropsondes. I like the sound of that.
Good, because our American friends have invented an ingenious dropsonde system. The gondolas they developed are capable of dropping about 50 probes during the whole of the balloon's flight. These little parachuted tubes can measure the temperature, the humidity and the wind.
Then, if you have the parameters of temperature, humidity, pressure and wind on all the surface of Antarctica from the stratosphere to the surface, you can improve the usage field of the YASI data in the polar regions.
Especially these parameters were impossible to obtain on a surface as vast and inhospitable as Antarctica.
How do you know where to drop the probes?
That's the job of Meteor France in Toulouse. They know the important zones to analyze well in order to improve their forecasting. By looking at the positions of the balloon, practically in real time, they forward their demand to the Americans of the NCAR, who then send the command of dropping the dropsondes to the balloon.
A real teamwork, in fact. But I still have a question. How do you pilot your balloon?
We don't pilot them.
How come?
Well, we let go of the balloon, then they move on their own, carried in the wind. The unique feature of this type of balloon comes precisely from the fact that they follow air masses circling the pole. Don't forget, you're in the vortex, and the vortex
goes round and round.
I have an interview on my computer of Mr. Herzog of the CNRS.
During the polar night, the stratospheric circulation over Antarctica is essentially determined by the huge polar vortex. At the end of winter, when the CONCORDIASI campaign starts, the vortex surface is typically 3 times that of the European continent. Strong westerly winds that isolate the vortex from the rest of the atmosphere can exceed 200 kilometers per hour. To study atmospheric dynamics and chemistry in this very specific region, we released about 20 long-duration balloons. The balloon trajectories are shown in black on the video. The balloons drift at about 20 kilometers altitude and are trapped inside the vortex, just like air masses. When time goes on, planetary scale oscillations that disturb the vortex make it finally break by mid-December. By regularly performing measurements along the balloon trajectory, we are thus able to monitor the whole stratosphere over Antarctica.
Okay, So that's why you drop so many of those drop swans?
We have used 12 balloons, dropping 50 probes each, which makes 600 probes. And for that matter, there! My friend Florence Rabier will explain better than me.
Speaking about me?
Yep, and you're late. This lady here is finishing her article before the program. We were talking about drop swans, or should I say, your speciality.
My speciality. You see, on each and every point on this map, they give us very precise measurements, which can be used to check models and YASI satellite data measured from the same spot at the same time. The geographic coverage is simply astounding, not only on land all over Antarctica, but over all sea ice too, in places where, in normal circumstances, no direct measurements can be taken.
Thank you, Florence. So all those measurements only help you improve the usage field of the YASI data?
Actually, no, they also help understand the waves of that region. When the wind drifts over an obstacle, like a mountain or a cloud, behind the obstacle, the air mass is going to start vibrating. The wave created will propagate in the atmosphere. Our balloons undergo the effect of the disturbance made by these waves, so we can observe those waves and understand the dynamic of the atmosphere better.
It's true, explained in this way, it all seems easier.
Shall I go on to the case of the hole in the ozone layer?
A hole that's getting bigger, if I'm right?
No, not at all. The hole in the ozone layer is a cyclic phenomenon that can be observed from September to January when the vortex is present. Today, we know there has to be a specific context for the destruction of the ozone. Some chemical species, stratospheric clouds, and sunshine. The clouds enable to free the molecules of chlorine produced by human activity. Then, under the action of the sun, these molecules destroy the ozone.
I can imagine these instruments observe this reaction.
We have a particle counter, which enables us to monitor the stratospheric clouds, and an ozone meter, which precisely measures the quantity of ozone present in the air.
An ozone meter. Usually I tend to forbid myself the use of words which sound too scientific, but this time I feel I understand. Thank you very much.
You're welcome.
I can nearly imagine planning my next holidays in Antarctica.
And why nearly?
I can't stand the cold.